So for my project, I decided to research 802.11 standards. I chose this topic because I think wireless networking is pretty interesting. I think it's easy to understand that data is being transmitted between devices when there's a physical cable connecting them. But with wireless networking, you don't have that. So I just think it's neat to have data being transmitted through the air basically between devices and then showing up in one piece on the receiving device. So I wanted to kind of research that. I also didn't completely understand the differences between the standards in the book for some reason, so I thought it would be good to further my knowledge on this subject. And through my research, I discovered that there are a bunch of 802.11 standards, so like the book, I'm only going to touch on the ones that I think are major. And then also go into some future technologies that are scheduled to come out soon and that I think are just neat and wanted to talk about them, so I'm going to go into that a little bit at the end as well. So to begin, the Institute of Electrical and Electronics Engineers created that first WLAN standard in 1997. It set the basis for all the standards after it, and they all kind of define some similar things, including media access control and physical layer specifications. So your Ethernet MAC addresses are defined in these, and then also your CSMA CA rules, which is that carrier sense multiple access collision avoidance. So to kind of re-explain what that is, only one device can send data at a time in a wireless network. So a device will send its data, and if it doesn't get a response back, it will set a random wait time and then try the data again. That's that CSMA stuff, and that's defined in these standards as well. This original standard's max bandwidth was 2 megabits per second, and it ran in the unlicensed 2.4 gigahertz ISM frequency band, which we talked about these back in chapter 6, but unlicensed frequency bands just means that anybody can use it without paying a fee. So lots of devices use the ISM band, industrial, scientific, and medical devices. So lots of wireless phones, microwaves, different equipment like that uses this band, which can cause some issues with interference because this band is not very wide, so a lot of the channels overlap. So that could be an issue. The standards all kind of build on each other and attempt to make some modifications to improve the wireless networking world. So 802.11b came out in July of 1999, and it upped that max speed to about 11 megabits per second. And it still used that 2.4 gigahertz frequency band, meaning that it was still getting some interference from microwaves, wireless phones, and other household devices. However, most Wi-Fi still runs on 802.11b today, mostly because it has a decent speed and you get a pretty good range. So it's basically just your basic Wi-Fi, if you have a concept of that. So pros of this standard are that it's low cost and it has a decent size range. Cons are that it's not the fastest. It's an okay speed, but it's definitely not the fastest of the standards that we're going to look at, and you're getting interference from home appliances on this frequency band. 802.11a was created around the same time as B. Some people seem to think that A came out after B because it didn't really gain as much popularity as B did, but they were actually made around the same time. It was a little bit more for business environments, and it was a little bit more costly, and that's part of the reason why it didn't really gain as much popularity as B did. Its max speed was 54 megabits per second, and it actually operated in the 5 gigahertz frequency band. So this band is still unlicensed, so anybody can use it without paying a fee. However, it's a little bit larger, and so not as many frequency channels are overlapping, which means you're going to get some less interference, and not as many devices use this channel as the 2.4 gigahertz channel. So again, you're going to be getting less interference. So pros are that you got a faster speed and less interference. Cons are that higher cost, like I said, and because you're at a higher frequency, you're going to get a shorter range. And it's also going to be a little bit more easily obstructed, meaning it's going to have a harder time getting through walls and other physical objects, which can be a problem when it comes to transmitting data. The next major standard was 802.11g, which came out in 2002. It kind of attempted to combine the pros of both A and B, because the two weren't compatible since they were on different frequency bands. You couldn't use one device that used B and one that used A. So G kind of attempted to get the best of both worlds. Its max speed was 54 megabits per second, like A, but it operated on that 2.4 gigahertz frequency band, like B, so you're getting faster speed with a decent range. It was also backwards compatible with B, so when this standard came out, you didn't have to buy all new appliances. You could have some that ran on B and some that ran on G. So pros are that it's fast, it's got a good range, and it's not easily obstructed because it's on that lower frequency. However, it's more expensive, and you're still getting interference on that 2.4 frequency band. The next major standard was 802.11n. There were a few in between G and N that provided some smaller specifications, but the next major one was this one. And it's also the last one that the book talks about. So it came out in 2009, and it's also known as Wireless N. It can operate in either the 2.4 or the 5 gigahertz frequency band. And it also provides an optional feature of 2 concurrent wireless channels. So in comparison with the past standards that we've looked at, this has a max speed of 72 megabits per second. That's with one single channel like the others use. But this standard has the option of using a wider frequency range, which can allow for 2 concurrent wireless channels to be used, which ups that max speed to 150 megabits per second. It also uses multiple input, multiple output, and streams, which basically means that your NIC or AP can have up to 4 antennas and can theoretically send at 4 times the speed of one with only one antenna. That ups that max speed to 600 megabits per second. And we get that number from 4 streams of 2 wireless channels, if that makes sense. Also, the standard is backwards compatible with G and B, so you can use devices that run on either one of these together in the same network. And again, you're not having to buy all new devices for this standard. And there's a picture there of a router that uses that multiple input, multiple output setup with the 4 antennas. These next few standards are not mentioned in the book, but I just think they're interesting, and I wanted to look into them a little bit and show that information. So in 2013, we got 802.11ac, which is known as gigabit Wi-Fi, because it's the first wireless standard that had a max speed of about 1 gigabit per second, which is about 20 times faster than 802.11n that we just looked at. It operates in that 5 gigahertz frequency band, but because you're in a higher frequency and you've got a higher modulation, you're going to have shorter range than the other standards that we've looked at. And you're also going to be a little bit more easily obstructed like we talked about earlier. Next, 802.11ad, which is WiGig, is a future technology that isn't technically out yet. We're starting to see some products with it now, but we talked about this a little bit in a discussion board in class. It runs on the 60 gigahertz frequency band, which is a whole lot higher than the other standards that we've looked at. And its max speed is theoretically about 7 gigabits per second, like 7 to 8, according to the different sources I looked at. And it makes claims such as being able to download an HD movie in 3 minutes, which standard Wi-Fi, that takes about an hour. So that's a huge difference. However, that higher frequency means you get a shorter wavelength, which means you get a shorter range. This standard only has a range of about 30 feet, which is not a lot. So you're not going to want to use this for your entire home or office. However, they're saying that this could be useful for wireless television and things like that. There is a possibility of devices that could maybe switch between Wi-Fi and WiGig, which would be nice because if you're within that 30-foot range, you can get that really high-speed internet and wireless access. But then if you're outside of that 30-foot range, you're still getting network access just at a typical Wi-Fi speed, which would be nice. And then lastly, 802.11ah, or Wi-Fi Halo, I think it's pronounced Halo, is another future technology. It actually has a frequency range of 900 megahertz, which is the first standard below 1 gigahertz, which is really interesting. So it's got a really low wavelength, but because of that, its range is nearly twice the size of typical Wi-Fi. And it also more easily penetrates obstacles, like walls and furniture. So they're hoping that this could be a really big step in the technological world in terms of like medical and smart car and smart home, things where walls and different stuff, it's really important to get through in long distance. However, it's not very fast because of this really low modulation. You're not going to get very high speeds. So that's the only downside to Wi-Fi Halo. And lastly, I found this neat image that I thought was a pretty good representation of the different standards I talked about. This red line that you're seeing on the outside is 802.11af, which I didn't talk about. It's another future standard that operates on an even lower frequency range than Wi-Fi Halo. It's in that 54 to 790 megahertz, as you can see. So you're getting a very long range. And it's, again, not out yet, but it'll be interesting to see how that looks. And then this blue line you're seeing, that's Wi-Fi Halo, and the green is BGN, which is in that 2.4 gigahertz range. A and C you can see in there on that orange line with the 5 gigahertz, which again is a shorter range. And then in there inside the house, 802.11ad or WiGig, which that 30-foot range is in there at the 60 gigahertz. So that's all I have. Here are my references, and thanks for your time.